we have today's session, which is a social justice and technology panel. We're featuring 3 professors from the University of Rhode Island. We have Professor Krishna Venkata-Subramanian, Professor Victoria Chavez, and Professor Sarah Brown as well. And they're gonna answer a couple questions that I have prepared today. So I'm gonna stop sharing this screen so that we can see the folks that we're gonna be talking today. All right. So the first thing that I would love to ask our panelists, and we'll start with Professor Brown, is could each of the panelists introduce themselves and give a brief description of their work?
Hi, I'm Sarah Brown. I'm a professor at URI, as she mentioned. And in my research, I study how machine learning algorithms and AI gets biased by the way that the world is biased, and what we can do to prevent that and to mitigate that and to make AI make a better world instead of reproducing our past.
Okay. Thank you. And next up would be Professor Chavez.
Hi everyone, good morning. Thank you for being here. So my name is Victoria, I use they and she pronouns. I'm a lecturer of computer science at URI. A lot of my work focuses on the introductory courses and how we can make those courses more inclusive for all of our students. I've done some research around how to make curricula more accessible for students with disabilities. And I'm really interested in how to best support our undergraduate students.
Okay. Thank you. And last but definitely not least, if we could have Professor Venkata-Subramanian.
Hi everyone, I'm Krishna and I'm an assistant professor in the computer science department at URI. And my area of work is in human-computer interaction, cybersecurity, and artificial intelligence. And most of the time I'm focused on helping people who are marginalized in our society get access to better technology to keep themselves secure, safe, as well as do well in life overall. So I do a lot of accessible technology work, and I think I'll talk more about it in a few minutes. All right.
Yeah, actually, you are up first, so we'll just segue.
Oh, am I? Okay.
Yeah, so we'll segue right into your question. So, like you just said, a lot of your research is around designing solutions to address real-world problems pertaining to people with a variety of disabilities and addictions. Could you discuss one project of yours and its implications?
Okay, so well, as Desiree just mentioned, I work on technologies focused on people with disabilities and people with addiction disorders and so on. One of the projects that I would really like to talk about that I'm really proud of being part of is an effort that is ongoing between my group, Worcester Polytechnic Institute in Massachusetts, and the state of Massachusetts in helping people with intellectual disabilities to report abuse. So if you don't know what intellectual disabilities are, they're basically intellectual deficits or social skill issues, or folks who have difficulty performing daily activities of daily living. So they need sometimes they need extra help to go about their lives. And for folks who are in this vulnerable population, it turns out that the level of abuse that they face is extraordinarily high. A recent FBI report estimated that as about 7 times higher than everybody else, and it's terrible. And so abuse in this case can be of many types. Some of them are obvious examples like physical abuse, emotional abuse, verbal abuse, sexual abuse. There's also neglect, where people don't get helped when they need help. There's financial abuse where people steal from them. So there's a lot of really, really big problems, and it's a very big issue. So the state of Massachusetts has been, I've been working with the state of Massachusetts to figure out how we can empower this particular population to be able to report such abuse. So right now what happens is that the reporting infrastructure is basically you have to make a phone call to a specific agency, like a social service agency in Massachusetts, and tell them that something's happened. Now this whole infrastructure is very ableist in nature, which means that it is designed for able-bodied folks. it's not really designed for people with intellectual disabilities to use effectively. So now think about it. In any other situation where somebody is a victim of a crime, they themselves usually report. They say, okay, well, somebody mugged me, somebody hit me, somebody did something. In this particular population, it turns out that they themselves have no real good agency to report. Somebody else has to do it for them. So what typically happens is that some neighbor, some friend, some doctor, someone noticed something changed with this person with intellectual disability, and then they go and report. So we want to kind of change that a little bit, and we want to empower people with intellectual disabilities to report abuse themselves. And so we've been spending a lot of time trying to understand this community. So I'm not somebody with intellectual disability, so I can't design for that community until I understand the community. So this brings me to the concept of human-computer interaction, one of the basic tenets of that field, which is that we try to really understand the community, the people who are interacting with these computing systems before we build anything for them. So in the opening video that you guys all saw, there were lots of examples of tech computers being used for, clothing manufacturing, to art, to next generation medicine and stuff like that. But one of the things that is kind of almost implicit in all those examples was that these computing systems will interact with people. And the moment they interact with people, you have to understand how people use these computing technologies. And only then can you really design good interfaces between the computer and the human, so that the human can effectively use those technologies. So in that context, we have spent almost 2 years trying to understand how people with intellectual disabilities live, what do they understand, what don't they understand, what difficulties do they face, and so on. And so far we have discovered that people with intellectual disabilities need help not only with reporting, but also identifying abuse. So many times when they're abused, they don't even know that they're being abused, because abuse can be so subtle sometimes. Sometimes people could be like, giving you backhanded compliments all the time. And sometimes people may be gaslighting you, if you know what that term is. If you don't know, I'll explain. But it's basically making you believe the world is a certain way when it's not. And these kinds of things are so subtle that everybody falls prey to it. This is not just people with intellectual disabilities. So imagine how difficult it must be for them. So we are spending now a lot of time in education, even though we didn't start out with that in mind. So this is hopefully very useful. So one of the other things is that this whole CS4RI, there was a huge focus on programming. Everybody was talking about how much you should all learn programming. That's very important. Everybody should learn programming. It's almost like math and reading skills these days. Everybody needs to know a little bit of programming. But what is even more important is understanding what to program and where to use it. And if you don't do it, if you don't spend the time to understand the problem that you're trying to program for, you will really build bad products. Bad outcomes will come as a result. The classic example that's given, and I'm kind of going all over the place here, but a classic example that's given is social media. I mean, think about the way these social media platforms are built. I mean, we saw Mark Zuckerberg, a very young Mark Zuckerberg in that video, talking about how great it is that 1 billion people are around. But I see the negative sides of Facebook in my research, where Facebook is used for bullying people. Facebook is used for threatening people. Facebook is used for creating hate environments. And that's not good for anyone, right? So these technologies were built at a time and scaled up to become so large without thinking about, like, it was built by a generation of people who really did not think about social implications of these technology, like what could go wrong, who could be affected badly. And that is something that we absolutely have to avoid in the next generation. So your generation, as it becomes more prominent in programming and it takes over the world, basically, you have to be very, very careful and think very seriously about what technology you're building, how is it helping people, and how is it potentially going to hurt people, and how do you minimize that? So that again brings me back to human computer interaction. You really have to understand your audience. You really have to understand the people who are going to use these technologies. Like we did, we spent 2 years trying to understand people with intellectual disabilities before we started to even build something. So programming is very important, but you don't just willy-nilly program something. You have to spend a lot of time trying to understand what you're trying to program. Anyway, I think I should stop. I can rant on forever, so maybe this is a good time to stop.
Thank you so much. No, that was great, and it perfectly sets up the next question, which I'm going to pass to Professor Brown, which is talking about how important it is to understand what you're programming, because it could have ramifications on populations that are sometimes not even known. Most of the times, not even known to the programmers who start to develop their technology. And so, Professor Brown, your research addresses biases in AI. Could you discuss how biases manifest in artificial intelligence and what we're doing to address this problem?
Yeah, so I'll start with a little bit about what AI actually is and what it means, and that'll help reveal how why the biases come into play. So when we talk about AI, most of the AI that's current and modern, and the reason AI is so popular right now is because of machine learning. And what machine learning it means is that instead of a programmer sitting in their office somewhere, writing some code, making a product, making a piece of software, and sending it out into the world, what the programmer does instead is they write an algorithm that tells a computer how to find patterns in data. And then they collect a whole bunch of data. They give the data to the program that they wrote, and then their program writes another program. And they send the program that they didn't even write into the world. They just trusted their program to write another program and send it off. And so what that results in is that the AI just does what the world looked like. It does whatever the data said to do. And you get the data from the world, and we know that people are racist, and people are sexist, and people are ableist. People aren't nice to one another. So when you let a program write another program from data, it just makes patterns matching from the data. So you end up with really bad things happening. So it comes into play often because the programmers who decided what data to use and who wrote the algorithm about how to learn from that data, like what's the important part of the data? How do you tell the important part? They didn't understand that part of the world they were putting the data in. They just like, oh, well, I can have data. Data could look like this. And they think about it in the magical, imaginary worlds that we can create with math, instead of thinking about in the real world where they're going to send their programs out. So one example of this happening was with a chatbot that was given a social media account. And it was named Tay. And they had this whole natural language processing thing, and it could like tweet ideas, and it would be able to follow trends, and it would tweet like, you know, takes on music, and it was supposed to be really fun, and it was supposed to be able to engage with people and reply to them. And I think it took like 6 hours before everything that Tay tweeted was horrifically racist and like really, really terrible, terrible things, because the programmers that built it, the ones that, you know, worked with it at Microsoft, they themselves didn't tell it awful things when they were testing it out and building it. But when they put it out on the internet and let anyone interact with it, people on the internet are bullies. And so it learned really terrible things. So when you don't think about how it's going to be used and how it's going to interact with the world, you can accidentally make really terrible technologies. And so in terms of thinking about how other types of bias get into these things, one of the really popular, or not, well, I guess it's commonly used examples of a biased AI system is called Compass. Compass is, excuse me, Compass is an algorithm that is purchased by police departments. And what the company that sells Compass says it does is that it will give judges a prediction of how likely, a score for each person who's arrested. It'll give them a score on a scale of 1 to 10, where 10 means they're probably going to commit another crime, and 1 means they're very unlikely to commit another crime. But the way this compass algorithm works is that when someone gets arrested, if you're in if your police department uses compass, they, with a social worker or maybe a police officer, do a survey with you. So you don't get to, the person who's arrested doesn't get to actually fill the survey out themselves. They have to save their survey answers to another person. So we don't know actually what gets recorded. And then that survey goes into the compass algorithm. And then it gives out a score and it goes on. So some journalists didn't think that's very fair. They thought that the way our courts are supposed to work is it's supposed to be based on evidence. If the judge is making a decision, it should be based on like, what's the facts of the crime? What are these things? It shouldn't be based on something. So they thought that was unfair on its own. And so they did some investigating. So they got a bunch of data from one county in Florida, and they got everyone who was arrested 3 and 4 years prior to when they were collecting their data. And then they had the truth. So they had their compass scores when they were arrested. And then they had 2 years after they were first arrested, had they been arrested again or not. And what they found was that, so in that particular county, there's very small numbers of Latinx and Asian people. So they just looked at only Black and white. And they found that Black people got high scores and then never got arrested again, twice as often as white people who got high scores and didn't get arrested. And that white people would get a low score and get arrested way more often than Black people that got a low score. And so they didn't think that was fair. The people that built it were like, oh no, it's fair because of this other definition. And then the people went on back and forth, the statisticians, machine learning people, went back and forth arguing about which definition of fair was the right thing to do. But it goes really back to not understanding the population and what's going on. Because the survey was designed based on criminology theories. And social scientists would tell you that criminology theories are the ways in which people tried to make science up to enforce their own racist ideas. So the questions and the data that the statisticians were arguing about was completely based on ideas of like, well, if you think it's okay to steal, then you're probably going to commit crimes. Or if you think if you're poor enough, then you should be able to do this. Like it's okay to do that. Like, and so it was all based on these theories that were based on, that have largely been proven false, but because they're still sort of out there, this company put them in their survey. So that's kind of the problems that we're working on. And so what I do is, even though I'm trained as a machine learning researcher, I learned my schooling, my education was focused on how do I build new algorithms, how do I take data, how do I find patterns, how do I produce these things. Instead of getting into this, which definition is better and how do we do what, I focus on trying to change the way we can learn from data so that we can learn from data even when we don't trust all of it. So we can learn the part that we trust, and we can not learn the things that we know are bad about the data. So what do we do if we think that this data is like 60% trustable? How do we learn from that? And so some of the things that my students have been able to do is find better definitions so we can measure how biased an algorithm is, and we can check, and we don't have to have that fight about which definition is better because we have a definition that can cover all of them together. So we found better ways of defining it by taking a step back and saying like, well, there's bigger problems, and looking at the whole picture and thinking about where our data comes from, why it is what it is, and then we can focus in and get back to the math and equations, because we have to at some point use equations to be able to tell computers what to do, because computers aren't smart. They need simple math. But by taking a step back and looking and thinking about where the things are going and how the world works, we're able to come up with better ways of reformulating our plans and our code.
Great, thank you so much. And with that, I can pivot into another question too that I have, is that when we're talking about how all of these, social theories and are often steeped in racism and sexism, and they're old and they have been debunked, but because our history is so steeped in these isms, they just keep perpetuating. And so moving into that history space, technology, it's a rather new development in humanity, but already a lot of its history has been distorted. And we're predominantly taught inventions and histories of programmers who are white and male. And so this next question is for Professor Chavez. And could you shed some light on why this stereotype of white male kind of nerdy programmer exists? And also share with us some contributions that are often, not talked about in the space.
Yeah, absolutely. So I love sharing fun facts. I'm not good with trivia, but I know some random fun facts about computer science history. And computer science really, most of the pioneers were women, right? A lot of the first programmers were all women. Actually, the first computer programmer was a woman, Ada Lovelace. And a lot of the technological advances that led to a lot of the advancements that led to the technology that we have today were happening during World War II. So during World War II, we were working on trying to create computers that were physical computers, because at the time, computer was a term applied, or it was a job title. So women who were mathematicians and were performing these mathematical computations or calculations were called computers. But we were working on trying to figure out, how can we do this faster, right? These women are amazing and they're doing this as fast as they can, but when you're at war, you need to do this in seconds, right? Not minutes. And that time can really make a difference. So they were working, there were a bunch of engineers working on creating these giant machines that would be able to perform these calculations significantly faster. And because the men who a lot of the men in the country were out at war, right? They were deployed out in the field. Mostly women were the ones who were at home and they were performing these jobs. They were mathematicians, they were scientists, they were going back to school to be able to get these jobs, and they were the ones tasked with programming these giant machines. Now, keep in mind, these machines were ginormous. They would take up entire rooms. And so programming wasn't just, I have a screen and I'm going to type out this code and the machine is going to do something. They would run around this giant room, flicking switches on and off in the correct order and timing everything appropriately so that they could have this giant machine essentially be a very, very fancy calculator. So we had, women were the first programmers, and because of the type of work that it seemed like eventually when programming was more type-based, and they were typing, it was seen very secretarial work. And Margaret Hamilton, who coined the term software engineering and was promoting it, she was the person who wrote most of the software for the in-flight Apollo mission, so to be able to get us on the moon. She coined the term software engineering, and people would look at her funny, right? And said, that's not engineering. You're not working with tools. You're not working hard. Like, this isn't STEM. This isn't engineering. And it wasn't until, post successful mission, realizing that because of the code that she wrote, our astronauts didn't crash and burn and die, right? Because she had to put so many safety guards in place to make sure that if anything on that ship or rocket was wrong, that it would alert the astronaut, that it would alert them and say, hey, something is up with this, do this, right? And that when they were landing, that whatever buttons they were pressing would actually perform the correct tasks. And that, that realization gave software engineering the authority is not the right word, but it gave it that sense of it is an engineering, right? It is something where you're problem solving and you're doing all of these tasks. So there's a lot of really, really interesting history that like Desiree said, gets forgotten, right? We don't talk about the fact that women were the first pioneers. We don't talk about the fact that, it was a Black man who created the first sellable video game cartridge, right? And without his technology, we wouldn't have things like the PS4, or I guess now PS5, and the Xbox and the Wii. Because back in the day, you had to buy, if you wanted a game, you had to buy a whole separate console, right? So imagine, now it's so easy. You can just download the games, right? And before that, you would just buy the CDs. And before that, you would buy the different cartridges. But back then, you had to buy a whole box, a whole console. You would plug it into your TV, and that's how you would play the game. And thanks to this Black man, Jerry Lawson, who created this technology, right? And it was cheap enough where they were able to sell it and commercialize it. That is why we have the technology we have today. And all of that story doesn't get told, and it doesn't get told because we don't have all of the representation that we need and technology. People are going to highlight what they know. And if in school we only get taught one side of history because one side wrote it, then we're not going to learn all of the stuff, and it's going to perpetuate over and over. So ask questions, look things up, look, find those folks who know the history and who can share the stories, and look for representations, because representation really does matter, right? Who gets a seat at the table is so important. And for those of you, I mean, I've been to Scituate, right? I taught at Scituate for a couple of months. You know, it's a great school. It's a very homogenous school, right? And so a lot of you have a lot of privilege, right? A lot of you are white. A lot of you are in this area where you're not necessarily exposed to a lot of different cultures. There are a lot of different identities. And it's so important that when you have a seat at the table, right? And when you're the ones making decisions, you are able to use your platform, use your privilege, use your space to bring other people to the table and say, listen, I know that I was the one who was hired for this job, or I know that this is my task, but I really think that we should bring in the voices of these people because this is also going to affect them. And that's the best thing that you can do. You can give the space and the platform to other people.
Great, thank you. And with that, that's a really important kind of takeaway too, that, you know, we're all in this no matter what our identity is, to make sure that we are making progress in this space and making sure that we're achieving justice and equity for everyone. So no matter what identity you hold, you're still valuable in making sure that this space is changing for the better. And with that, my final question for the panelists, and this is up for grabs for anyone and multiple people can comment, is talking about the sort of justice movements that we're seeing in both the United States but across the world today. So many media outlets and research publications are looking at how this new era of activism is happening in digital spaces. This has kind of been really pushed in the era of COVID too, because we can't necessarily all go out and participate in a safe way. And so there's a lot of creativity that's happening, and how do we get justice out there through media platforms? So I was just curious what the panelists think, if they could speak to the implications of digital activism and maybe some pros and cons of digital activism.
I can start, I guess. So I think one really cool pro is that it can be global, and we can share things, and we can you know, rally behind people in a completely different part of the world to support them. And one of the really fun examples of that was over the summer when some bad things were trending on Twitter, and the K-pop fans started taking their hashtags over every day, and they would just turn them into images of you know, K-pop, or they would turn them into memes, or they would turn them into, at one point they became pancakes. And it was just, this is what we're doing now. It's not your hashtag where you get to have your conversations about whatever bad things you're talking about. You know, the ways you're talking about your racism, you're playing all your stuff. We're going to fill it with our completely jokes and fun images instead. And so I think that there's a lot of opportunity for us to engage and kind of elevate and like shift conversations, and to cooperate in ways and scales that we wouldn't be able to otherwise. And I think the cons really is that some people also have less access. And so that can change if, and I think we see it also in when we're looking at the bias, these algorithms and the AI that's biased, the people who are at the bad side of it, who are receiving the bad outcomes, are the most marginalized people. And so if they, you know, don't like that they were denied a loan, they tend to not have a way of even like, because they don't understand, they don't have access to knowing how computer science works, they don't have access to even asking the questions. And so there's a lot of room for improving access and improving understanding of these things in order for people to actually protect themselves when technology is is a part of the problem.
Great, yeah, that's an amazing answer. Thank you. And we have maybe time for one more. I think we end at 9:30. So if anybody else has anything to add.
So one thing that I would add to what Professor Brown just mentioned is that access has two elements to it. So when we talk about online activism and stuff like that, that's great. A lot of these things can be done by people who are in a highly connected environment. You have access to a good phone network, you have high-speed internet, you can sit at home and do, organize and all that. That's great. But in the US, US being particularly bad at this compared to other, more quote unquote developed countries, is that there's a huge portion of US where there's not good internet connectivity. There's not even good phone network. And we are kind of a weird, even if I say so myself, in the sense that we are a weird country that we're building satellite internet, and Elon Musk is building, Starlink and stuff like that. And we can't get basic wire connected to a rural community. We spend so much money trying to do some random stuff that may benefit people in 30 years time, maybe to send people to Mars or something, but we can't get good internet connectivity to people. I'm not sure how bad or good things are in Situate, but there are lots of rural areas in the US where there's no good internet connectivity. So we always talk about internet connectivity being one of the things that needs to be provided, that access needs to be provided. People need to get access to good infrastructure to be able to participate. That's only one part of the story. That's a very, very important part of the story. Don't get me wrong. The other part is accessibility, and accessibility in the sense of, okay, I have a computer, but I can't use it. I have good internet connections, but I can't use it. Why? Because I don't have upper body mobility, right? So one of the projects that we're working on, for example, is trying to build better login systems for people with upper extremity impairment. So folks whose arms, hands, fingers are not dexterous, they don't work as well as other people, right? So think about it. Everybody a lot of you may use like Face ID or something like that, where you place the camera in front of your face and it recognizes you. But think about what it takes to do that. You have to move your hand up. You have to take a selfie, kind of, basically, right? But what if your hand doesn't work? What if your arms don't work in the same way, right? Now you're depriving this group of people from having access to a very, very powerful and good security technology, right? So what about people who can't type because of their hands don't work? So now how are they going to tweet, right? How are they going to post things on Instagram? How are they going to take a selfie and post on Instagram? How are they going to become an influencer if they want to, right? So accessibility, or making technology that is accessible, usable for all types of people, is very important. And that is something that technology development that happens these days makes a lot of implicit assumptions. Like, they make these assumptions without even thinking about it. They make assumptions about who is going to use my technology. And they don't think about people who nobody thinks about. I mean, who thinks about people who are disabled? Who thinks about people who have intellectual disability? Who thinks about, in the olden days, it used to be that if you're a person of color, nobody thought about you. Now that has improved to some extent, not really 100%, but it has improved to some extent. Now people with disability, they're speaking up and saying, think about us, don't leave us behind. So to be able to do that, for everybody's voice to come up, you need to build technology that works for everybody. Imagine if there was a technology that did not work for white people. Imagine that. Imagine if your camera could not capture your face effectively, that you could not use Face ID, right? It worked for me, somebody with my complexion, but it did not work for you. Now, I'm not trying to bring color or anything like that into this conversation. I'm just making a kind of an extreme example to make a point. Imagine if your technology did not work for you and you alone. It worked for everybody else. How would you feel? So put yourself in a person's shoes who cannot walk, or who cannot use their arms, or who cannot speak, or who cannot hear. And what would it take for technology to be made accessible to them so that they can use the technology and they can have their voices heard as well? Because one thing that I have kind of learned from my work in this space with accessibility and people with disabilities and stuff like that is that I'm temporarily able-bodied. I'm not going to remain able-bodied all my life. As I get older, my body is gonna become, I may become disabled over time. In that case, I would want technology to be still able to help me and allow me to do everything that I do right now. So anyway, it's important to not only have access to technology, but also make the technology accessible. And only then everybody's voice will be heard effectively, I think. Anyway.
All right. Thank you so much, all of you. I appreciate you joining us really early in this morning to be on this panel and all the insights. So I hope that folks were able to learn something new and to take away that computer science and technology is really, really important, and that we need everyone to be thinking about these systems moving forward. And hopefully it has sparked your interest in computer science if you didn't have one before. So with that, because I know we're a little bit over, I will let everyone go. And thank you so much for joining us this morning.